All right, so I wanted us to finish up chapter 9.3, but before we finish up the last couple of examples with side, side, side using the law of cosines, I want to go back to this case 3, where we used the law of sines in order to solve for A. Now, you end up getting A is sine inverse of 2 times sine 60 over root 7, and you get about 40.9. Now, that's only one of two possible answers. And it was asked in class, well, how do you know whether or not the other solution works? And I started talking about ranges and this and that, and I wanted to just make sure we had that down so we could refer back to it. It was a great question, and I'm glad that we could kind of work through the solution together, but I want to make sure that it's down on paper so that there's no confusions about this. So we'll go ahead and block this off, and we'll say, all right, the range of sine inverse is negative pi over 2 to pi over 2. Now that is quadrant 1 and quadrant 4. So this is fine, and this essentially cuts us off. The problem is that we know that, in fact, on the unit circle, right, if sine hits any value here, it's going to hit the same value here. So the problem is that this is our theta 1 and this is our theta 2, that our sine inverse didn't give us that. It gave us both. Excuse me, it didn't give us both. It only gave us this one, this 40.9. Now, in another problem we did last time, we did this, right? We ended up doing the same thing. You ended up with sine b equals this whole thing. So we did sine inverse of this, and you got b is 0.43, which is 25.4. But that's not the only possible solution, right? Because sine inverse is just between negative pi over 2 and pi over 2, it's only going to give you solutions in the first or fourth quadrant, but there is a solution in the second quadrant. So here we did 180 minus our solution in the first quadrant is 154.6, but the problem is that was too big, right? Because if we took this 154.6 and added 40, you would get like 190 something. That's too big. So you end up with a pretty similar situation here, where the sine inverse spits out one solution, but you know that there has to be a second solution in quadrant 2. So this is the solution in quadrant 1, this is quadrant 4, and this is the solution in quadrant 2. So sine inverse only gives you this. So you have to be a little bit careful, because it's possible that this solution in quadrant 2 is going to work. Now, if we did this, we would say, okay, this is 180 minus, I'm going to round it to 40. 180 minus 40 is 140. So is this solution going to work? All right, well, 140 plus 60 is 200. That's too big. So this solution isn't going to work. So I believe, I'm trying to remember in class, I talked about the sine inverse is going to tell you that this isn't a solution, because it's not. This second one isn't a solution for sine inverse, because it's not, right? We have to cut off sine inverse, but it is possible that it could be a solution for our problem, because our sine inverse doesn't give us all the information that we need. So we just have to be a little bit careful about that. So in this case, we'll say that this theta 2, excuse me, theta 2, I keep drawing Q, yeah, is 180 minus theta 1, which, as I said, is approximately 139.1, and that's too big. So then 139.1 plus 160 is simply greater than 180. 139.1 plus 60 is greater than 180, so this won't work. So that is, now that it's on paper, exactly what is happening, and we can refer back to it, because I feel like maybe it was a little confusing while I was kind of giving my explanation, because I was working through it in my head as I was explaining it. So I just want to make sure that we have the relationship between what sine inverse is going to tell us only in quadrant 1 and quadrant 4, but it's possible there's something in quadrant 2, and so we just, we found that by doing 180 minus the solution that our sine inverse gave us, but then that turns out to be just too big given the angle that we already have. All right, so let's swing on down here. So for this, we have A is 4, B is 3, and C is 6. Now here, use the law of cosines to find the largest angle in the triangle. So can we know off the top of our heads what is the largest angle? The answer is yes. The largest angle is going to be opposite the largest side. So that means we want to solve for big C first. So we'll say C squared equals, let's go up here, double check and make sure we get it right. A squared plus B squared minus 2AB cosine C. All right, so we can now solve for cosine C, and you end up getting, or we'll just solve for C, is cosine inverse of C squared minus A squared minus B squared over negative 2AB equals 6 squared minus 4 squared minus 3 squared over negative 2 times 4 times 3. And that gives us approximately 117.3 degrees. All right, from this we could then solve for the next largest. The next largest is going to be A. So we have A squared equals C, should be B squared plus C squared, but it doesn't matter, minus 2BC cosine A, and let's double check that up here. B squared, C squared, perfect, all right? Now this gives us that A is equal to, you just plug in for the same thing, same layout, and you get about 36.3 degrees. And in that case, you then have B is 180 minus A minus C, and this turns out to be about 26.4. So that is how you would solve for all three of these angles. So we'll do another example down here. In this case, A is the largest, so we're going to start off with A. So just to save time, I'll go ahead and write it as what it looks like at the end. But if you solved for it, you'd get cosine inverse of 10 squared minus 8 squared minus 5 squared, all over negative 2 times 8 times 5. And this gives you 97.9. Next, we could solve for B, and B is going to be cosine inverse of 8 squared minus 10 squared minus 5 squared, all over negative 2 times 10 times 5. And this gives you approximately, let me make sure this is approximately, 52.41. And then similarly, you get C is 180 minus A minus B, and you just get 29.69 degrees. All right, how's about number 5? So in attempting to fly from Chicago to Louisville, a distance of 330 miles, a pilot inadvertently took a course that was 10 degrees off, as indicated in the figure. If the aircraft maintains an average speed of 220 miles per hour, and if the error is discovered after 15 minutes, what angle should the pilot turn to head towards Louisville? So there's definitely a lot of moving parts to this problem. So I'm going to draw a much bigger triangle, and we'll see what happens. So I'm going to label things. I know that this is 10 degrees. I know that this is 330 miles. I don't know this. I'm going to call it A. And this down here is the theta that I'm actually looking for. So first things first, I think that I am going to need to solve for this distance. This is the distance that the pilot flew before recognizing his mistake. Now, luckily, this one at D is relatively easy to solve for, right? The distance is just the velocity times the time. The velocity is 220 miles per hour. Now, he flew for 15 minutes, so that's 0.25 hours. So this is 220 divided by 4. And this turns out to be 55 miles. So this is our D, it's 55. So next we can solve for this. We'll call this our X. So we know that X squared equals 330 squared, excuse me, plus 55 squared minus 2 times 330 times 55 times cosine of 10. Now, the reason that we did this is because this gives us our 3 sides, right? And now that we have our 3 sides, or once we finish this, we'll have our 3 sides, then we can solve for this A here, and then we can find theta by 180 minus A. So if we do that, you get that X is equal to about 276 miles. All right, so now we can find A. So I have that A, so we'll say 330 squared equals, so this is 55 squared plus 276 squared minus 2 times 55 times 276 times cosine of A. Okay, so what exactly is A? So in this case, we will solve for A, and you get that A is cosine inverse of 330 squared minus 55 squared minus 276 squared over negative 2 times 55 times 276. And this gives you a very large angle. It gives you 168, approximately 168. So that's what this angle A is, though. But that's not what we want. We want theta. So theta is just 180 minus A, and that gives us 12 degrees. So the pilot needs to change course by 12 degrees in order to get back on track. And that is how we do this problem. So if there are any questions, please let me know, and I will see y'all on Wednesday.